Warm welcome to all of you in this revision class for today. Because it's like CH2 and CH5, both of the classes, I have to make revision together. That is why I didn't give different time, because it's like it's the same course. So, I mean, why do it twice when we can just make it in one class? So I have, for CH2, I created the session, but for CH5, I copied the link. I have created announcement on Blackboard. I send the link by email, section email as well. And I also WhatsApp to Yara, the leader of CH5, to send it to the groups for the students to join. Okay, but I can just see here 16. I don't know where the rest of the students, because I have approximately one section 20 students, one section 19 students, so 39 students. But I don't know. I mean, was it mutually decided the timing between CH2 and CH5? Okay. Okay, in that case, it's okay. So, because in this case, I won't be able to wait for other students, because the time was 12, and I don't want to waste your time, because your exams are also coming. So let me share my screen to start. Just a second to start the things. Okay. Is my screen visible now? Okay. Let me discuss first from here along with the PowerPoints. So we have a total of 10 experiments. First, synthesis of benzoin. Second, synthesis of oxidation of benzoin ila benzyl, or synthesis of benzyl. Then third was synthesis of benzylic acid. Fourth one is synthesis of metanitroacetophenone. Then chemoselectivity in reduction of metanitroacetophenone. Then synthesis of 3,5-dimethylpyrazole, synthesis of benzimidazole, extraction of limonene from orange peel. Then experiment number 9 was synthesis of orange dye, and experiment number 10 was synthesis of phenol formaldehyde resin. So all 10 experiments will be there in your exam, final exam. And we have final exam this subu al-jay يوم الثلاث إن شاء الله من صباح إلى اثنين صح in the laboratory. We decided, I mean, all the sections we have this the same time. Okay, it's on Tuesday. Just a second. My research student messaging me. Anyways, I just told her that I'm having my revision class. Anyways, so all 10 experiments will be there. For, I mean, few things we need to make it clear, that we don't have any IR, we don't have any NMR. Then you need not to, memorize the physical properties. No, it's not on Wednesday. لا يوم الثلاث. هذا موجود في الجداول يوم الأربعاء. Was it present in the timetable for your exams ولا لا؟ Do you got your timetable for? Okay, I'm just asking, do you got your timetable for lab exams? Okay, no. So it's like يوم الثلاث 23/4. I mean 23 ربيع الثاني. يوم الثلاث. From 1 to 2. في الجامعة. In the university. So you have your final exam on Tuesday. Coming Tuesday الأسبوع الجاي يوم الثلاث من الساعة 1 إلى 2 في الجامعة. In the university, I think كلية العلوم. Just like your mid واحد. Just like your mid 1 exam. Okay, so let me make a few points clear here that we have 10 experiments. All the 10 experiments will be there in your exams. Second thing is this, you will not get any IR or NMR, and also there is no need for physical properties. For example, melting point, what is the melting point? I'm saying mechanisms, yes, you have to. Because it's like we have to, because it's not on blackboard. Otherwise, you would have got a thing not to do mechanisms, but this exam is in university. So mechanisms, yes, important. All the mechanisms. That's why we have cut short NMR and IR and physical properties. Because we know mechanisms are important for you. Yeah, just to, I know it's a lot, but if we would have put IR and NMR and physical properties, that would have been huge. That is why we have removed IRs and NMRs and physical properties, just to make it lighter on just mechanisms, reactions, and procedure. Bas. So the first experiment is synthesis of benzoin. This is the reaction mechanism. So for example, let me just tell you the pattern of your question paper. Okay, you will have 10 سوال اختياري. 10 سوال اختياري, choose. Then the second question is complete the following equations. So there are 4 tafaul which you have to complete it. For example, I might give you this one, benzaldehyde, arrow, and this structure. Then you have to write here NaCN ethanol. For example, I give you this structure, I give you arrow and write ethanol. So you can write down this catalyst and the final structure. So there are 4, complete the equations. Then mechanism, there is only one mechanism. So you have to be very careful, because there is one mechanism and that mechanism need to be camel. Because when I was correcting your mid 1, I came across that when you are writing mechanisms, there are no arrows, no nucleophile, no electrophile. Bidun electrophile nucleophiles and for example OH minus and H plus, your reaction is not complete. I mean, mechanism is not complete. Reaction is like A at the foul, B gives C. It's okay. But mechanism is a whole procedure. So you have to be very careful with mechanism. Then there is one more question about calculating the yield. So I know for calculating the yield, you all are perfect. So let me start with these. Synthesis of benzoin. Hina benzaldehyde yatafoul sodium cyanide in presence of ethanol to give benzene. This reaction is known as benzoin condensation because this is a condensation reaction. Hina, it results into formation of alpha hydroxy ketone. Benzoin is alpha hydroxy ketone. These very small points, but very important points. So, hina benzaldehyde, yatafoul sodium cyanide, and ethanol. It gives us benzoin. This reaction is known as benzoin condensation. And the final product, benzoin, is alpha hydroxy ketone. So this is the name of this murakkab in general, benzoin, alpha hydroxy ketone. That benzaldehyde yatafoul sodium cyanide to give us alpha hydroxy ketone. Here the catalyst is sodium cyanide. Sodium cyanide, basically it's a complete molecule. The cyanide ion is the catalyst. Cn minus. Okay, so this is the proper mechanism. I don't want to go into mechanisms again because mechanisms, you have to memorize all the 10 mechanisms. I mean, there are not 10 mechanisms. We don't have mechanism for limonene. And yeah. Okay, I will make it more easy for you. Just a second. Do you want me to give some experiments specifically from which you can study mechanisms? Or you will study all? What do you want? Okay. So, just a second, let me see and I will let you know. I will give you experiment numbers. I mean, okay, these two, last two. Start min hina, for example, because we took this in mid 1, experiment number 1 to 4. Then 5 is chemoselectivity. 6, 7, 8, 9, 10. Okay, so you can take mechanisms from the complete mechanisms, but might be there are questions on mechanism for, I mean, maybe in ikhtiyari, but for writing down the mechanisms, I'm cutting short that you can take the last 5 experiments. And in this experiment, limonene peel, there is no mechanism. So just remaining 4. 3,5-dimethylpyrazole, benzimidazole, orange ethylene dye, and phenol formaldehyde resin. So out of 10 experiments, just 4 mechanisms. The last one, excluding this one, orange peel, because there is no mechanism. So 3,5-dimethylpyrazole, benzimidazole, orange ethylene dye, phenol formaldehyde dye. 1, 2, 3, 4, 5, 6. तजुर्बा रकम 6. 7 9 و10. Okay. Do you got it? 4 experiments for mechanism. 3,5-dimethylpyrazole, benzimidazole. The last 5 experiments لكن بدون orange peel. So you just have 4. 6 7 9 و10. Okay. Pyrazole, benzimidazole, orange ethylene dye, and phenol formaldehyde resin. You are welcome. So it's like these 4 mechanisms you should be doing completely, kamil, so that you can write it down. Like it might be a question on general mechanism fil ikhtiyari. Like it will be ikhtiyari, so it's easy. So it's not like you will not study mechanism for other experiments. Study mechanism for other experiments just for, giving the, okay. It's like for mechanisms, for writing the complete mechanisms, I have cut short from 10 experiments because, yeah, I know it's a lot. But still, I have cut short with IR and NMR and physical properties. There is no need for IR, NMR, and physical properties. Only 3 things: mechanisms, tafaulat, and procedure. So in mechanisms also, you can, I just made a, you can say, cut off from the total 10 experiments. Now, it's like you can just study these 4 mechanisms for writing the complete mechanism. But this doesn't make sense that you don't study other mechanisms. Might be other mechanisms, they have questions fil ikhtiyari. Lakin these 4 mechanisms, which I will be telling you the experiments, these 4 mechanisms might be there. Write down the mechanism of fala, fala, fala. So you don't have to study for writing the mechanism, the whole mechanisms. Just study for ikhtiyari sawalat. So the 4 experiments which you should know each and every step of mechanism for writing is tajurba raqam 6, 3,5-dimethylpyrazole, tajurba raqam 7, synthesis of benzimidazole, tajurba raqam 9, synthesis of orange dye, and tajurba raqam 10, synthesis of phenol formaldehyde resin. واضح؟ Okay. So experiment number 1, synthesis of benzoin. Tafaulat you should learn for all the experiments. For example, benzaldehyde ya tafaul sodium cyanide ethanol gives what? Because there are 4 questions on, or 4 or 5 questions on complete the following equation. So you should know the final product as well as ish موجود فوق ولا تحت الارو هنا. So benzaldehyde yatafaul sodium cyanide. So when, or it's like we have 2 units of benzaldehyde here. So benzaldehyde yatafaul benzaldehyde in presence of sodium cyanide. Cyanide act as a catalyst to give us alpha hydroxy ketone. This murakkab in general is alpha hydroxy ketone. The name of this murakkab is benzoin. And this reaction, tafaul al-kamil, is known as benzoin condensation. So this is the general mechanism. I'm not going into mechanism. Just study mechanism for by keeping in mind that you might have question in ikhtiyari. Okay. Then the second experiment. Second experiment is synthesis of benzyl. So this reaction is oxidation reaction. Benzoin ila benzyl. Benzaldehyde ila benzoin was condensation reaction. Benzoin ila benzyl is oxidation reaction. So here, benzoin, it react with HNO3. You should know these reactions specifically from your practical book. Just a second. So tafaulat min hina, your lab book, these are important. Okay. So benzoin yatafaul HNO3 gives us what? So it gives us benzyl plus nitric oxide. So here HNO3 is used for oxidation of benzoin. So this alpha hydroxy ketone benzoin, this undergoes diketone. These are, you can see, diketone here. This is alpha hydroxy ketone. Then the third experiment is synthesis of benzylic acid. Benzylic acid synthesis, just like synthesis of benzoin had a condensation reaction. Synthesis of benzyl, it is oxidation reaction. Then synthesis of benzylic acid, this is rearrangement reaction. Okay, this reaction is rearrangement. So benzyl yatafaul aqueous KOH in presence of ethanol give us benzylic acid. So you should know all these things here above the arrow, below the arrow, and also the final product to complete the reaction. Okay, one point here is this was a mistake made by students in middle awwal. This reaction, synthesis of benzylic acid, had a Mafi acidification reaction. I wanted to clear this point. Had a Mafi acidification. Why not acidification? I mean, this is, there was a confusion between students, benzyl and benzylic acid. Most of the students were wrong in this question. Acidification means the reaction, it doesn't mean the reaction takes place in presence of acid. Acidification means you got a salt, lebadu, you put acid to the salt. This is called acidification. Lakin, for example, tafaul hina, this benzoin, ya tafaul HNO3 give benzyl. The reaction is taking place in presence of acid. This is not called acidification. Acidification means you have a salt, lebadu, you put acid to decompose the salt to get your final product. That is called acidification. Acidification doesn't mean that your reaction takes place in presence of acid. Hina reaction is taking place in presence of acid, HNO3. Mafi acidification. Nafsa shay hina. Here reaction is taking place in presence of aqueous KOH, potassium hydroxide base. So when this potassium hydroxide, so this reaction is taking place in presence of a base. Now, when this KOH yatafaul benzyl, it gives you potassium benzylate, hada salt. Now this potassium benzylate, now you add the acid. And this process is called acidification when you are breaking down the salt into murakkab. Is this clear? What does acidification means? Acidification doesn't mean the reaction taking place in presence of acid. La'a. Acidification means when you are decomposing a salt ila murakkab. Clear? So here, the first reaction was condensation reaction in presence of sodium cyanide, where cyanide act as a catalyst, result into formation of alpha hydroxy ketone benzoin. Second reaction, synthesis of benzyl. Synthesis of benzyl had an oxidation reaction. Here, benzoin in presence of HNO3. HNO3 act as an oxidizing agent, not an acidification. Okay. So when it reacts with HNO3, it gives us diketone, which is benzyl. So this reaction is your oxidation reaction. Then synthesis of benzylic acid. Now here, the reaction is taking place in presence of a base, aqueous KOH, result into formation of potassium benzylate. Now you have a salt, potassium benzylate. So we add your acid to it, and this process is called acidification. So this formation of benzylic acid requires acidification. And this reaction is rearrangement reaction. Okay, synthesis of meta-nitroacetophenone. So here acetophenone, yatafawal HNO3 and H2SO4 give us meta-nitroacetophenone. HNO3 and H2SO4, they act as nitrating agent. And when you nitrate, when you react acetophenone with HNO3 and H2SO4, it gives us meta-nitro, not ortho, not para, only meta. So nitration of acetophenone gives us meta-nitroacetophenone. And here the ion, here the ion used is nitronium ion. Okay. Then chemoselectivity in the reduction of meta-nitroacetophenone. So we have meta-nitroacetophenone by previous experiment where acetophenone, yatafawal nitrating agent, HNO3 and H2SO4, it gives us a nitro group, fill meta position fakat, mafish ortho, mafish para, this meta only. So meta-nitroacetophenone. Now this meta-nitroacetophenone can give reductions because it has two groups. Nitro group can also be reduced ila amino, and this group can also be reduced to alcohol. Okay, so you have to remember the reagents. That nitro ila amine in presence of tin and HCl. Ketone is converted into alcohol in presence of sodium borohydride in presence of ethanol. So when meta-nitroacetophenone, ethanol and HCl, tin and hydrochloric acid, then this nitro group is reduced to group. Okay. And when this meta-nitroacetophenone, it reacts with sodium borohydride, hina nitro group remains nafsa shay, lakin this ketonic group gets reduced to alcoholic group. So here, this meta-nitroacetophenone has two groups which can be reduced, nitro and this ketonic group. Lakin, when in presence of tin and HCl, nitro group is reduced to amino group, amine group, or amine group. And in presence of sodium borohydride, there is no effect on nitro group. Lakin, this ketonic group is reduced to alcoholic group. Then synthesis of 3,5-dimethylpyrazole. So here we start min acetylacetone. This is a 1 wahid talata diketone. Wahid itnin talata. Wahid talata diketone also known as 2,4-pentane dione. Yatafa'ul hydrazine hydrate. Ethylene murakkab of moya is eliminated. Give us this murakkab, and then it undergo resonating form, hydride shift basically, to give us 3,5-dimethylpyrazole. Remember the structure? The name of the following is structure 3,5-dimethylpyrazole. Why 3,5? Those who are studying halaqiya, they know that we start numbering min hina, hada wahid, hada ithnain. This rakam is talata. So we have talata, methyl. This is arba, and this is khamsa. So we have 3,5 methyl group, mawjood marratain, so di. So 3,5-dimethylpyrazole. This is the name of this murakkab. Okay, synthesis of benzimidazole. Hina, in synthesis of benzimidazole, we are using 1,2-diamine, phenyl or we can also write orthophenyl. So hina orthophenyl diamine yatafaul formic acid. Hina mafi HNO3, mafi H2SO4, mafi acetic acid, and it's not also other acids. Fakat formic acid. So orthophenyl diamine or wahid ithnain phenyl diamine yatafaul formic acid HCOOH. It gives us benzimidazole. Then extraction of limonene. I hope you remember this thing. Just a second. Here, because there is not much to remember things in limonene, but these structures are important. This is the structure of R-limonene. This is the structure of S-limonene. You should know the structures properly, which is in right, which is in left, because these are enantiomers. These are mirror images. So for limonene, you should know that there are two enantiomers, R and S, and you should know the structures of R and S limonene. So this figure is important. Clear? Because this is the only thing in limonene, R and S. Enantiomers, we have enantiomers of limonene, R and S, R limonene and S limonene. So this figure is important. Properly structures, they are enantiomers. Why? Because they are mirror images. For example, hina hada mawjood fil left, this is present at right. Double bond CH2 mawjood fil left, this double bond CH2 mawjood fil right. Double bond hina mawjood yasar, hina mawjood yamin. So this figure is important. Okay. Okay. Experiment number 9. Synthesis of orange dye. So when you study reactions for complete the following equation, study tafaul min hina from your revised practical book. All the reactions mawjood hina. And the second one, this one which I sent, this is for mechanisms. You just study mechanisms min hina. You don't have to study these reactions. Okay? Reactions min hina faqat. Revised practical lab book. All tafaulat. So hina sulfonilic acid, we have not used sulfonilic acid. We have used aniline. Aniline, yatafaul sodium hydride in presence of HCl gives you N2Cl plus. This you should study from the Jadid one, which I send it to you. Synthesis, experiment number 9. No, not this one. This one. I emailed you. This is the reaction. NH2 sodium nitride in presence of HCl gives us benzene disonium chloride. This in presence of ethane naphthol in presence of NaOH give us this 2-naphthol aniline dye. So here mechanism. This one. This is a very important mechanism. Synthesis of synthesis of dye. It's not orange dye. It's a simple azo dye. Okay. So these are the steps: formation of nitrosonium ion, libado formation. It's like formation of N-nitrosoamine. This one, and then coupling reaction. Clear? This is a very important mechanism. All these. Step 1, diazotization, this one, and step 2, coupling reaction. Okay, so the first step is called diazotization, where you get aniline is converted into a salt called benzene disonium chloride. And then this benzene disonium chloride, Acetophenone, your whatever alcohol. So we use beta naphthol. So this reaction, the first step is called diazotization. The second step is coupling reaction. Here we always maintain the temperature below 0 degree Celsius. Okay. The last experiment, synthesis of phenol formaldehyde resin. You should study tafaulat min hina. Okay. Phenol, yatafaul formaldehyde in presence of basic catalyst give us ortho and para-hydroxy methyl phenol. And when this ortho-hydroxy methyl phenol, yatafaul phenol, it give us novolac. Novolac had a linear polymer. And when ortho-hydroxyphenol, yatafaul para-hydroxymethylphenol, it give us bakelite. Bakelite is a crossed link polymer. So this tafaul is also important. That phenol, yatafaul formaldehyde in presence of basic catalyst give us ortho plus para-hydroxymethylphenol. But when this ortho-hydroxymethylphenol, yatafaul phenol, it gave us a linear polymer novolac, while ortho-hydroxymethylphenol, yatafaul para-hydroxymethylphenol, it gave us bakelite, which is a crossed link polymer. Okay. Then this also I have emailed you, synthesis of phenol formaldehyde resins. There are two types of phenolic resins, rhisol and novolac. So rhisol is synthesized under basic pH conditions with excess of formaldehyde, while novolac is synthesized in acidic pH with excess of phenol. So these two important points between rhisol and novolac. Rhisol is made under basic pH with Zaid formaldehyde. Novolac is made under acidic pH with Zaid phenol. And novolac had a linear polymer and bakelite had a crossed link polymer. Then these mechanisms, you will study for sure. That's it. Any more question? You don't have to memorize the procedure. For example, you do it in ice bath, you do it in general, you should know. but focus main on tafawulat. What are the starting material, what is the final material, what is catalyst use, and mechanisms specifically, and especially the last four mechanisms which I said for the 3,5-dimethylpyrazole, imidazole, and azodie, and phenol formaldehyde resin. So you just have to focus main on mechanisms. Tafawulat, you have to be on focus. And then what type of a reaction, condensation, oxidation, rearrangement, or what is the product, for example, benzoin had alpha hydroxyketone, benzyl. Sorry, Riyu, for bonus, I have asked. They said we cannot make any bonus because you already have 70% from your reports. So until and unless we are worked with it, because it's like 15 only for mid one. If it would have been a different course with 20 for mid wahid, 20 for mid attani, 40 for ikhtibar and nihai, in that case we can make bonuses. This I asked, but they said for labs we cannot. Any other question? Okay, how about calculating the yield? Okay, I have, let me write it down, murakkab A gives murakkab B. Sah? So whatever murakkab I am going to give you, I will give you the molecular weight. For example, hena, mia, hena, tamania. Okay. So now how you will calculate the experimental yield. So experimental yield, for example, if we start it min hena, 2 grams. So, you know, we calculate the experimental yield, the amount which we have used upon 1 upon the molecular weight of the starting material into coefficient. This was also a common mistake in middle awal, that I got students who doesn't write molecular weight of the starting product hena. Rather, they make molecular weight of starting material fil folk and final material fil tahat. That will be a wrong procedure. And also the coefficient hena, if there is mafi rakam, that means wahid by default. Hena mafi rakam mawjood. So coefficient is wahid min wahid upon 80 upon wahid. 2 4 is 8, 2 5 is 10, 4 2 is 8 upon 5, and then you can use your calculator. This grams. So this is how you calculate the theoretical yield. 1.6 grams. 1.6 grams. Stunning. 2 into 80. Okay. Then this was your experimental yield. This is what you got. Or this is theoretical yield. What I calculated, is it experimental or is it theoretical? Theoretical, because this is the mistake which students made in ikhtibar. This is not experimental.
Experimental yield is the yield which you get badal tajarub. This is you are doing calculations. This is your theoretical yield. Clear? This is not experimental yield. Most of the students, they make mistake. Experimental yield is, as the name says, experimental or obtained. This yield you get badal experiment, badal tajarub. And when we calculate, this is called theoretical yield or calculated yield. So your theoretical yield from ethane gram is 1.6. So experimental yield which we get, suppose this was equals to wahid gram. So we can calculate the percentage yield. This is equals to actual upon theoretical or theoretical upon actual. How do you calculate? Actual upon theoretical, A upon T. So this is equals to actual is 1 grams, 1 upon 6 multiplied by 100. Always, okay, one more, you can say a shortcut here is that experimental will always be less than theoretical. Experimental yield will always be less than the theoretical yield. So whichever is less, you put fil fawq. Whichever is zaid, you put fil tahat. Theoretical yield will always be the yield which is zaid, which is more. Experimental yield will always be less. Always aqal min theoretical yield. Always. So the small value fil fawq, the bigger value fil tahat. Always. So one thing is this. Then second, for example, I have ethane of A gives me B. For same question, 100 grams. Oh, sorry, 100 moles per gram. This is molecular weight. We start with ethane grams. So we calculate the theoretical yield. Ethane gram. So ethane into 1 upon 100 into, what should I write now? 1 upon 2. You forgot everything. Why it will be 1 upon 2 or 2 upon 1? Which will be fil fawq? Product upon reactant or reactant about product? You decide first among yourselves. Because this is the most important thing I taught to you during the classes. Product upon reactant, reactant upon product, what? And this I have done with you ala tool for all the 10 experiments. So first you decide what is it. Product upon reactant or reactant upon product. These are very small mistakes which we do. And then when we do it, we get, the answer is wrong, of course. Yes, product upon reactant. Okay. Product upon reactant. Yes, from here, we just convert it, coefficient of product, upon coefficient of reactant. So product hena is wahid, hena reactant is ethane. Clear? Because this need to be cleared off. Just give me a minute, please. Rahaf, I will give you the degree for reports because it's like I have 40 students and I have 10 reports for each student. So 400 reports I have to check. So because I have to make re-exam as well. So once I finish my re-exam, and then I will start doing it up, inshallah. But I will finish it in this week. I have already started, and I will finish in the coming week so that I can send you the degrees out of, the report plus your middle hour, inshallah, in this weekend. Just give me a minute, please. Okay. So I was writing here, ethane A gives us B. We start, this is the molecular weight, 100 grams, 100 gram per mole, hina tamania. We start with ethane gram. So theoretical yield will be ethane into, this is gram, ethane into 1 upon 100 multiply by hina. You will have fog is your product, tahat will be your reactant. So hina hada wahid and this is ethane into hina this fog upon 1. Zero 0.8 grams. So this is your theoretical yield. Experimental is suppose 0.5. So percentage yield equals to صغير على طول في الفوق زايد على طول في التحت. Or you have, this is theoretical, this is actual yield. So actual upon theoretical, A upon T. A comes double T, A, B, C, D, E, F, G. So A is your actual yield ala tul fil fog and theoretical ala tul fil tahat. This is how you calculate another thing. Okay. The third point in calculating the yield. Second test questions. Second test, I didn't understand. Second test, for re-exam, there is no mid-2. Just re-exam for those students who were absent because of corona. And they have a valid reason. They have a report. They submit it into the department. And department has sent us the list that these are the students. So we have to make a re-exam for them. Mafi Midattani. And even as I said, for re-exam, it will be in the last experiments. Mid one, do you think we need to solve it? Okay. Okay, in that case, my laptop's battery is running. But let me just finish for your final exam first. Okay, I got it connected now. So this is how you calculate the yield. Now, another thing is, for example, when you have this percentage yield equals to actual yield or experimental yield or obtained yield upon theoretical calculated multiply by 100. So if I give you any of these things, I will give you any two things, then you can calculate the third one. For example, I give you actual yield and theoretical yield, you can calculate the percentage yield. If I give you percentage yield and theoretical yield, you can calculate the experimental yield. If I give you percentage yield and experimental yield, you can calculate the theoretical yield. Is this clear? And this we have already discussed how we can do it. Okay, so this was about calculating the yield, theoretical yield, how you will calculate the theoretical yield. Please remember the formula which I have told you. If you make a mistake, if you write the formula wrong, it will be wrong. It will not be correct. And also, if I give you two things out of here in this equation, percentage yield, experimental yield, theoretical yield. So in that case, if I give you two things, you can calculate the third one. For example, I give you these two, you can calculate the percentage yield. For example, if I give you percentage yield and theoretical, you can calculate this one. Remember, if it is fil tahat, if it go hina, it will be multiply. If it is above, always remember that left hand side and right hand side sign changes. If it is plus, it will become minus. If it is minus, it will become plus. If it is multiply, it will become divide. And if it is divide, it will become multiply. Let me just give you one example. For example, percentage yield is 80%. And actual yield is, suppose, ethane grams. Theoretical yield is, you have to calculate the theoretical yield. Okay. So now what will you do? This will go above and this will come down. So theoretical yield equals to ethane upon thamanine into 100. So this is equals to 2 divided by 80 multiplied by 100, 2.5. For example, if I give you this 80 and I ask you to calculate the actual yield, the experimental yield, I give you theoretical yield, 2.5. So this will go here, 80 into 2.5 equals to your experimental yield. And this 100 hina mia multiply, so it will come hina fil tahat. Yes. So maybe the full question may be like this. Yeah. So calculating the yield has these points. Calculate the theoretical yield, calculate the percentage yield, and if out of these three, I can give you two, you should be able to calculate the third one. Okay? The same revision is for your the final exam. Okay. Let me open up your mid one. Okay. Regarding your mid one, I cannot share the screen. Okay, the first question was, what type of reaction take place upon treatment of ketone or aldehyde with HCN to form a cyanohydrin? That aldehyde yatafoul HCN to make a cyanohydrin. Just a second. Because if I don't share my screen, how you'll be able to understand? Okay. Okay, the first question was, what type of reaction take place upon treatment of ketone or aldehyde with HCN to form a cyanohydrin? Nucleophilic addition, nucleophilic substitution, nucleophilic addition, or electrophilic substitution? So let me just show you here. This one. The question was that when we add, what type of reaction take place upon treatment of a ketone or aldehyde with HCN to form a cyanohydrin? So this question was for experiment number 1, where your benzaldehyde, yatafol sodium cyanide to give a cyanohydrin. So what type of a reaction is it? Nucleophilic addition, nucleophilic substitution, electrophilic addition, or electrophilic substitution? So as you can see here now, this is your benzaldehyde, right? And this HCN, you get it from NaCN. Yes, Vad, it is nucleophilic addition. So now you can see here now, this is cyanide, other nucleophile. And it is always nucleophile with attack. So the first thing here is nucleophilic. So your electrophilic are out, right? Then you have to see whether this is nucleophilic addition wala substitution. So here, as you can see here, this is a cyanohydrine. Here you have not removed anything. Elimination means when you add something, you remove something. Substitution means whichever hada mawjood will be present along with this new one. So here, this O is here, hydrogen is here, carbon is here, and cyanide is also added. So this is a simple nucleophilic addition, Mafi substitution. Substitution is when you take the place. For example, if cyanide add, hydrogen is moved, hydrogen is deleted, then this become substitution. Here all the groups are mawjood along with cyanide. So this is a simple nucleophilic addition. Clear? I will go one by one, question by question. So here this is a nucleophile. First thing, so electrophilic, all electrophile options are out. Remaining are nucleophilic addition wala nucleophilic substitution. Here this nucleophile is adding here. Mafi substitution. Substitution is like, for example, if I cannot come al-yawm, maybe I can, you have a class. Then I can ask Dr. Areem if she can take my class because I cannot come. So this is called substitution, in my place. So, lakin hina, this cyanide is joining on carbon, all the atoms, nafsa shay. No atom leave. In substitution, one atom leave and one atom join. Or two atom leave, two atom join. Lakin, addition hina is when you have all the atoms which were previously present along with this jadid one. Oxygen, mawjood, hydrogen, mawjood, carbon, mawjood, and cyanide group is added. So this is a nucleophilic addition reaction. Clear? The second question. Which medium is used in benzylic acid rearrangement reaction? Benzylic acid. So this is your benzylic acid. Okay, this is benzylic acid. Now the question is, which medium is used in benzylic acid rearrangement reaction? Neutral medium, strong basic, mild acidic, strong acidic. So here it take place in presence of KOH, potassium hydroxide. Hada mafi neutral, mafi acidic. So the remaining option is, because potassium hydroxide is a strong base. So the correct answer is strong basic. Clear? Third question. Which of the following syntheses need acidification? This was the common question where most of the students were wrong. Which of the following syntheses need acidification? 3,5-dimethylpyrazole, this was out because we have not studied this experiment until then. صح? We just make اختبار middle أولى فقط تجربة 1 إلى 4. And 3,5-dimethylpyrazole هذا التجربة رقم 6. So this is out. Second option is benzyl. Third option is benzoin. And fourth option is benzylic acid. Now it says acidification. You know, in synthesis of benzoin, so benzoin, benzyl, and benzylic acid are remaining. This is synthesis of benzoin. Hina fi acidification wala la. We don't even use acidic medium hina. So this is out. Sa? Then let's see the second one. Benzoin ila benzyl. This reaction takes place in presence of HNO3. Hada acidification wala la. Sa. It is not acidification. This means the reaction is taking place in acidic medium. Acidification means when you are decomposing a salt, hina mafi salt. Lakin when you go hina in this reaction, the third one, benzylic acid. Though this reaction take place in a strong basic medium, lakin when this potassium hydroxide yatafaul benzyl, I will just show you hina. Hina shufi. This is potassium benzylate. Now this salt is decomposed by HCl. And this process, fakat this process, this step is known as acidification. So acidification took place in benzylic acid. When we are decomposing potassium benzylate salt into the particular murakkab. Clear? Acidification doesn't means your tafaul take place fil acidic medium. Both of acidic medium wala acidification mukhtalif. Acidification faqat means you are decomposing a salt in presence of acid to get murakkab akhir. Clear? Then the fourth question, the addition of HNO3 to benzoin was done under steam bath, water bath, inside the condenser, and ice bath. So it's like benzoin with HNO3. So this was a very important point I discussed, that it was done on steam bath. Clear? Question number 5. The gas which is released during the synthesis of benzyl is NO3, HNO2, NO2, HNO3. So HNO3 itself had a nitric acid. This is out. HNO2, this is not a general, murakkab which takes place in reactions. Then we have NO3 and NO2. NO3 is nitric trioxide. The correct answer is sah, it is NO2. Nitric oxide and nitric oxide is your nitrogen dioxide, NO2. But some of the students, they gave me answer HNO3 and HNO2 as well. Okay, question number 6. The primary step in the mechanism of benzylic acid is, the first step in mechanism of benzylic acid is addition of potassium hydroxide, dissolving of benzyl in ethanol, dissolving benzoin in ethanol, addition of sodium hydroxide. So the reaction is about mechanism of benzylic acid. That means synthesis of benzylic acid. So this is synthesis of benzylic acid. So here, dissolving of benzyl in ethanol. Benzyl ila benzylic acid. So what is the first step? Here, addition of sodium hydroxide is out because here there is no sodium hydroxide. Second thing, dissolving of benzoin in ethanol is out because this reaction does not start min benzoin. This reaction start min benzyl. Now two options are remaining, addition of potassium hydroxide and dissolving of benzyl in ethanol. So because it is asking about the mechanism. Mechanism, the first step, as you can see here, is in presence of OH minus. And this you get from potassium hydroxide. So the correct answer is, the first step in mechanism is addition of potassium hydroxide. There is no role of ethanol in this reaction. So the correct answer was addition of potassium hydroxide. Now, synthesis of benzylic acid is a dash reaction. Reduction, oxidation, Wahid ethane rearrangement, Wahid arba rearrangement. Benzylic acid. This one. How come it is Wahid arba reuf? If it would have been arba, this position Wahid itnain talata, it should be somewhere hena, somewhere hena. Rahaf, there is no option of Wahid talata. Fakat reduction, oxidation, Wahid itnain, Wahid arba. Hada mafi reduction, hada mafi oxidation. Sah? There is no reduction, there is no oxidation. So remaining is Wahid ethane wa Wahid arba. This is Wahid ethane rearrangement because here the position is, this one is Wahid and this one is ethane. Wahid ethane rearrangement. We are not asking you about hydride shift. Hina hydride shift sah Wahid arba. Shufi hina. This one. If you see in a hydride shift will be okay. But this is a complete reaction. So Wahid ethane, just on position rakam Wahid and ethane. Bas. This is just Wahid ethane rearrangement. Mafi Wahid arba. We are not asking you about hydrogen shift. We are asking in general. The synthesis of benzylic acid is dash reaction. Reduction, wala oxidation, wala Wahid ethane rearrangement, Wahid arba rearrangement. So this is Wahid Ithnain, first and second position. This is your first carbon, this is your second carbon. Clear? Okay, in the following species, the one which is likely to be intermediate during benzoin condensation of benzaldehyde. Most of the students are correct here. Most of the students were correct. Okay. In the following species, the one which is likely to be intermediate during benzoin condensation of benzaldehyde. So which one? A, B, C, and D. During benzoin condensation, we make a cyanohydrin. So maybe these two. This is wrong. This is not a cyanohydrin. This is not a cyanohydrin. Hina CN, hina CN. Cyanohydrin sa. Lakin which one? Positive wala negative? Sa. Negative. C. The correct answer is C. Most of the students are correct on this. Most of the students. Here, if you see here, this one. pH for phenyl ring, C and cyanohydrin hina, and OH on other side with a minus sign. This is not a carbocation. This is a carboanion. Okay. The synthesis of meta-nitroacetophenone is dash reaction. And most of the students were wrong in this. Synthesis of meta-nitroacetophenone is dash reaction. Nucleophilic addition, nucleophilic substitution, electrophilic addition, and electrophilic substitution. Meta-nitroacetophenone. Meta-nitroacetophenone. Okay, this is your meta-nitroacetophenone. Now the question was, the synthesis of meta-nitroacetophenone is dash reaction. Nucleophilic addition, nucleophilic substitution, electrophilic addition, and electrophilic substitution. So this is your acetophenone. From nitric acid and sulfuric acid, we make nitronium ion. I says nitronium ion is the one, just like cyanide, Cn minus. In the reaction first, tajarob rakam wahid, benzoin. Hina nitronium ion, NO2 plus. Fill azodized formation, diazotization, it is nitrosonium ion. So this is your electrophile. So nucleophilic is out. Hina. NO2 hada mafi nucleophile. Hada electrophile. Now the question is, electrophilic addition wala electrophilic substitution? We have not asked you in mechanism. We asked the synthesis of metra-nitroacetophenone is dash reaction. Now, yes, Roba and Wad, you have written electrophilic addition, but the correct answer is electrophilic substitution. I am not talking about with you of this carboanion or you can say carbocation. I am talking about the final murakkab. In benzoin condensation, I was talking about cyanohydrin product. Lakin hina meta-nitroacetophenone, that means your murakkab fil akhir. Now, it cannot be an electrophilic addition. Why? Because this, if you add nitro group hina, okay, if you take it as addition, hina addition, lakin this double bond is not kamil. It becomes an ion hina. This is not your murakkab. So what actually happens hina is that this hydrogen has to leave, and in place of hydrogen, your nitro group will come, the same position. So this is electrophilic substitution reaction, not electrophilic addition. I will just show you here example. This is COCH3 acetophenone. Okay. Hina kamadad hydrogenat. Wahid hina. Wahid hina. Wahid hina. Wahid hina. Wahid hina. Khamsawad. Khamsa. Wahid itnin talata arba khamsa. Now this murakkab is kamil. Now I wanted to add a nitro group. So what happens? It come here at meta position according to mechanism. But in the last, what I get is the final murakkab, which I get is it's very bad in drawing. You have COCH3 here. Okay, the same double bonds here. Hydrogen here. Hydrogen here. Hydrogen here. Hydrogen here. Yes, remove one hydrogen and you put one nitro group. So this is called substitute the hydrogen. So this is electrophilic substitution. It's not like you can put like hydrogen is also here and nitro is also here. You have to remove hydrogen and then you will put nitrogen. This reaction is an example of substitution. Was it? If it would have been electrophilic addition, then you will have both hydrogen as well as NO2. Both of them mawjood. Lakin in that case, the valency will not be kamil because carbon can make only 4 bonds. Wahid, ithnain, talata, and the fourth one, yumkin hydrogen, yumkin nitro group. So we take hydrogen and we put nitro group. This is what we call substitution. Clear? So this was electrophilic substitution reaction. Okay. The next question then. Which from the following is the first step in crystallization process or procedure? Filtrate the solution at room temperature. Some of the students were correct in this and some of the students were not correct. Filtrate the solution at room temperature. Filter the solution at room temperature is the step akhir. We filter the solution. Then the second option, cooling the product. So cooling the product yumkin can be a step in between. Hada mafi first step. First step is you take your solid and you dissolve it in appropriate solution. You have your salb, murakkab al-salb. You dissolve it, fill solvent. Yumkin ethanol, yumkin methanol, acetone, any other thing. So first step is choosing the appropriate solvent that in which you should dissolve it. When you are doing recrystallization, your solid compound should dissolve in anything to become liquid. Then you heat it, libadu filter it, and then cool it. This is a procedure of crystallization. So the first step is choosing the appropriate solution, choosing the appropriate solvent. Clear? That your murakkab had a salb, solid. So you cannot do recrystallization of solid ala tul. You need some solvent. So the first step is choosing the appropriate solvent. And when you choose the appropriate solvent, the second step is dissolve your salb, murakkab in the solvent. Lebadu heat it or cool it. It depends what type of a technique you are using. And then filter it. Filter the solution under hot condition or filter it in room temperature condition. This are step yumkin tani wala talit wala rabia. Mafi step al-ula. Step al-ula, step number 1 is alatul, choosing the appropriate solvent. Okay, to determine the melting point of a compound, the substance should be pure, dry, both A and B, none of these. So when you do melting points, I have always told you that when you filter it, when you dry it, when it is dry and it is recrystallized, then we do melting points. So for melting point, your murakkab should be pure as well as it should be dry. So the correct answer is both A and B. So then the last question in MCQ is synthesis of benzoin require condensation of benzaldehyde with dash. So in benzoin condensation, aldehyde ya tafaul, sodium cyanide. So the correct answer was sodium cyanide. Some of the student, I don't know from where they selected the answer sodium acetate, sodium nitrite. Sodium nitrite is used in diazotization. And that we didn't discuss it by that time. So in benzoin condensation, benzaldehyde ya tafaul sodium cyanide. You know. This one, benzaldehyde ya tafaul sodium cyanide, NaCN, to give us benzoin. Okay, then complete the reaction. Starting with benzyl, draw and name the first and second step that happens during synthesis of benzylic acid. So here, in first bracket, you write benzyl. In second bracket, you write benzylic acid and name it as benzyl, tahat benzylic acid. Only this thing. And then in between, you made arrows. This was also okay. Above arrow was KOH and tahat is ethanol. Then name of the organic salt. I really don't understand that some of the students, they were not even able to draw the structure of benzyl or benzylic acid properly. Also, they name this structure as benzyl, wala benzoin. No, this is not benzoin. This is not benzyl. This is benzylic acid. When you are drawing a structure, you should know the name properly. Then the name of the organic salt formed during the synthesis of benzylic acid. So during synthesis of benzylic acid, we have this salt. This one, potassium benzylate. The name of the salt is potassium benzylate. Some of the students have written potassium acetate. Some of the students have written KCl. Some of the students, I don't know how come from where they have written KCl or HCl. I don't know. Then this is potassium benzylate. You have benzene rings here. If it is potassium acetate, it will be fakat CH3COO minus K plus from acetic acid. But this is benzylic acid from benzylate. So you should have benzene rings. Also, some of the students, they have made mistake in writing down the structures as well. This potassium salt is near the oxygen of carboxylic acid, mafi hydroxylic hena. These were very common mistakes which students made. They gave me structures like this, K plus, and they remove H min hena and they make it minus. La, carboxylic acid is more, acidic. And this one, when you see here, this one, this will give its hydrogen, not this oxygen from here. So if you write down here K plus and O minus, this is wrong. K plus and O minus should be from carboxylic acid, not O minus min hena from hydroxyl. Clear? This was the very common mistakes where the students made. They make K plus, they make the structures correctly, but it is not correctly 100%. But your potassium salt, K plus and O minus will be alatul from carboxylic acid, mafi min hina. Because carboxylic acid is more acidic than hydroxyl. So carboxylic acid will give hydrogen first. This Tani. Okay, the type of proton transfer that has been happened during synthesis of benzyl is, draw the steps. This question was cancelled afterward when students, they have a lot of issues. They were not able to write it properly. So we have removed this question. So there is no degree for this question. So, I need not to worry about this if you are right or if you are wrong. The nitration of acetophenone takes place in meta position. Explained by mechanism. So this is the mechanism. Whenever you write a mechanism, you should write tafaul awwal shay. The first step tafaul lebadu mechanism. The question is, nitration of acetophenone take place in meta position. Explained by a mechanism. So this is the whole mechanism you should write. This one. Stepwise, if you don't make arrows, if you don't write it like this, slow step, fast step, if you don't make nitronium ion, if you don't shift this single bond ila this positive sign, your mechanism is not Kamil. You should write down the complete mechanism. Bidun arrows, it's not a mechanism. Bidun electrophiles, nucleophiles, it is not a mechanism. And if there is slow step, if there is fast step, it is this electrophilic substitution. Here in presence of water molecule, because we have to remove this hydrogen min hina. So each and every step in mechanism is very important. Even if you skip any small point, you will lose degrees. So this was whole mechanism for synthesis of metanitroacetophenone. And in the last question, most of the students were correct, lakin some of the students were wrong in giving me the theoretical yield, which I said that they made it wrong in the formula. The formula for calculating theoretical yield is grams of starting material multiplied by 1 upon molecular weight of the starting material of the reactant. Wahid fil fawq, molecular weight fil tahat. But some of the students, they have written molecular weight fawq and wahid tahat. So that is wrong. And that too, some of the students were wrong in calculating the molecular mass of benzoin and benzyl. So when your molecular mass is wrong, your whole answer is wrong. That's it. This was your middle أولى. في أي سؤال يا بنات؟ Okay, this is it. And best of luck for your exam. And still, if you have any question for re-exam, those who had corona, or if you have any question for your final exam, you can WhatsApp me anytime, no issue. If you have any query or if you wanted to anything. I didn't got this, what you have written. So that's it. Best of luck for your exam. And in this weekend, inshallah, I will finish your reports, and then I can send you the degrees from 85, inshallah. Thank you so much, and best of luck for your exams. Stay home and stay safe, stay healthy. But your اختبار النهائي, it will be في الجامعة يوم الثلاث الأسبوع الجاي من الساعة 1 إلى 2. Okay? So if you don't have any question, then you can leave it. It's okay. Thank you so much.